Welcome back, everyone. This is Professor Rood, and I'm going to go over a few word problems for Chapter 2 on motion. So the first thing I want to look at is the speed of an object, or velocity. And the speed is equal to the distance traveled divided by how much time it takes to travel that distance. So let's take a look at this problem right here. Let me get a pen. And we have a bicycle travels at 12 kilometers and it takes it 40 minutes to do that. And they want to know the average speed in kilometers per hour, not kilometers per minute. So there's a red flag right there that you need to address the issue of units. Here's our formula. Speed is distance over time. 12 kilometers is the distance. So let's go ahead and put the 12 kilometers in for distance. Then I want to convert, that's not very good handwriting, I apologize. I want to convert my minutes into hours. So let's do our conversion. You're starting off with 40 minutes. And let's set it up like I tell you to set it up. How many minutes are there in an hour? And there are 60 minutes in 1 hour. Okay, so that comes out to be, oh, where are my notes? 0.666 hours. Let's just put 0.66 hours. All right. Now we can take this 0.66 hours and we're going to plug that in for time. And if you take 12 kilometers and divide it by 0.66 hours, you will get 18 kilometers per hour. Okay, so that is our final answer for this problem. In this problem, we are going to add vectors. There are two types of quantities, if you remember in lecture, scalar and vector. When we're changing directions, as we are in this problem, you cannot simply add the two distances together using normal math. So let's read the problem here. A ship travels 200 kilometers to the south and 400 kilometers to the west. What is the ship's displacement? So what we try to calculate is vector C here. Since we have a right angle triangle, we can use the Pythagorean theorem. A squared plus B squared equals C squared. We don't want to know C squared, we simply want to know C. In order to get rid of the square, we take the square root of both sides. So here's our final formula, and then it's just a matter of plugging in the numbers. So let's go ahead and do that. So we're going to have the square root of 200 kilometers squared. And then we're going to add the 400 kilometers. And we can't forget to square that one as well. And we end up getting then our final answer of, if you take 200 and square it and add it to 400 squared and then not forget to take the square root, you get 477 kilometers. Not the 600 kilometers if you would have done ordinary math. That's not what your answer is. You cannot do ordinary math when we're changing directions here. So our answer, once again, the ship's displacement, that is vector C over here, is 477 kilometers. Let's continue on with the next problem, which is an acceleration problem. And the formula for acceleration is equal to your final speed minus your initial speed divided by time. So it's a change in speed over time. So this problem says, how long does a car whose acceleration is 2 meters per second squared need to go from 10 meters to 30 meters per second? So in other words, they're asking how much time is it going to take for that acceleration to occur? Okay, so we need to rearrange this problem and solve for time. So let's just start by doing that. Okay, so I multiplied both sides by t to get rid of the t over here, and then I divided by a to get rid of the a on the left-hand side of the equation. All right, so let's fill in these. Our final speed is 30 meters per second, according to the problem. Our initial speed is 10 meters per second. So 30 minus 10 is 20 meters per second. And our acceleration in the problem says 2 meters per second squared. So 20 divided by 2 is going to give us an answer of 10 seconds. All right, so we have been talking about speeds of objects moving along the Earth's surface. Let's look at a problem where we're throwing something up in the air. And whenever we're throwing something up in the air or dropping something through the air, gravity is going to be involved. So this problem says a ball thrown upward at a speed of 12 meters per second. Should say a ball is thrown upward at a speed of 12 meters per second. When will it reach the top of its path? So if we're throwing it up in the air, we're going to have to use a different equation. And this was worked on by Galileo. And so the speed is equal to gravity times time. And so when will it reach the top of its path? How much time does it take? So that's what we're solving for. So if we rearrange and solve for time, time is equal to the speed divided by gravity. Simple calculation. Our speed in the problem is 12 meters per second, and gravity is 9.8 meters per second squared. So crunch that out on your calculator, and we will get an answer of 1.2 seconds. Going to disappear again. Sorry folks, I'm still learning how to use this. Oh, it stayed. Okay, so that was a fairly straightforward problem there. We need to use a slightly different equation when we're dealing with gravity, when something is falling through the air or you're throwing it up into the air. Let's do another problem here, and we're going to be dropping an object through the air. So a bottle falls from a blimp whose altitude is 1,200 meters. That's the height from which it's being dropped. If there's no air resistance, the bottle reaches the ground in how many seconds? So here's another one of Galileo's equations where the height is equal to 1/2 times gravity. It is falling through the air. We have to have small g there, times time squared. All right, so the relationship between the height from which the object is dropped and the time is a direct relationship. If one goes up, the other goes up, but it is not proportional, okay, because time is squared. So let's work this problem out. And we are solving for time in this. So this may be the hardest part of this formula, is rearranging the equation and solving for time. Okay, so in order to get rid of this squared, we're definitely going to have a square root on the other side. So I'm just going to put that in there right now. And to get rid of the 1/2, I'm going to multiply by 2, both sides. And to get rid of g on this side, I'm going to divide by g. and we have h on this side already, so it's 2h divided by g, the square root of all of that. So let's go ahead and plug that in to the formula. And we get 2 times 1,200 meters is our height. And we know gravity is an acceleration equivalent to 9.8 meters per second squared on Earth. So when you take 2 times 1,200 and divide it by 9.8 and take the square root of all of that, we will get 15.65 seconds is how long it will take to reach the ground. So we could just call it rounded up to 16 seconds. Okay, so a modification once again of the height from which an object, or the distance from which an object is dropped through the air. We always have to have gravity involved in the formula. All right, let's go to Newton's second law that says force is equal to mass times acceleration. So here we have a 300-gram ball that is hit with the bat, and they tell us the force is 150 newtons. If the bat is in contact with the ball for 0.02 seconds, the ball's speed is what? Its final speed. Its initial speed obviously is 0. So the first thing that I notice in this problem is that whenever we're dealing with force, we have to be in kilograms for mass. So let's just convert, we can do it down here, 300 grams into kilograms, remember? So we have 1,000 grams. If you don't know that, you look it up in your book, per 1 kilogram. And so it is equal to 0.3 kilograms. All right, so now we have the mass in the correct unit. So let's go ahead and rearrange this equation, because what we need to solve for is the acceleration. We're already given the force and the mass. So I like to rearrange my equation first. So force divided by mass is equal to acceleration. And 150 newtons divided by 0.3 kilograms will give us an acceleration of 500 meters per second squared. All right, so that is equal to acceleration. So what we're trying to solve here, keep in mind, is the ball's speed. So we have the acceleration, and we're going to solve in this equation here for v2. So we're assuming initial speed is 0 meters per second, okay? So that goes away, that just drops away. So if we rearrange the equation, we get v2 is equal to acceleration times time, and our acceleration was determined to be 500 meters per second squared, and our time is 0.02 seconds. That comes from up here in this word problem. And so our final answer for our final speed, v2, is 10 meters per second. And there goes my M again. All right, can't hold my pen down that long apparently. So here is our final answer.